Nice to see you there. Barely even noticed you snuck in. Good to see you anyway. Today we're going to be talking about observing celestial bodies, aka altitude and azimuth. That's what we're going to be focusing on, but celestial bodies nonetheless. So you might be asking yourself, what the heck is a celestial body? Well, I'm glad you asked. A celestial body is actually any natural body, aka amount of mass, outside the Earth's atmosphere. We say natural, so that includes things like moon, sun, stars, planets, asteroids, all of that jazz. But in our atmosphere, or outside Earth's atmosphere, we have a lot of other things too. So after we started sending things to the moon, we also have quite a bit of debris that's up there. So when we send up rockets and things like that, they get rid of fuel tanks and they some of their parts deteriorate, or maybe there was satellites up there too. Those aren't natural bodies. Those aren't things that happen naturally, so they're not considered celestial bodies, but they exist outside of the sun. All right. We're also going to talk about observation. So any celestial body is really positioned and recorded and observed using a coordinate system. So coordinate systems that we are used to, like the XY coordinate system on a Cartesian plane, is something that we could also use when documenting observations. So for example, if we had a point here on a Cartesian plane, where we had this red star, we can read that and write it as the point x comma y. On the x-axis, that's at a 12, and on the y-axis here, that's at the point 5. So we can record that star at the point 12 comma 5, x comma y. Alrighty, so when we are documenting our observations, there are two different coordinate systems that we can use, or at least the most commonly used ones. The first one is the right ascension and declination, and the other one is using altitude and azimuth. So we're going to describe a little bit about both of them, but we're really going to focus on altitude and azimuth, because that's the one that's a little bit easier to understand and something that we could actually use ourselves when referring to different objects in the sky, or just even objects here on Earth too. So, the right ascension and declination. So, the benefit or this advantage of using this model is that if you are an observer standing at any point on Earth's surface, your coordinates that you are provided using the right ascension and declination model will be constant. So if I'm standing at the North Pole, someone else is standing at the equator, and I say, hey, look at the stars, here are the coordinates using the right ascension and declination, we can both use those coordinates to find and look at that exact same object. So they are not location specific in terms of where that observer is located. Rather, they are good to go for any observer who's standing at any location point to observe the exact same object. Altitude and azimuth is not constant for any location where an observer is positioned. Rather, it is location specific. So if I am standing at St. Mary's at the front doors right outside the atrium, and I'm looking at a top of the tree and give you the altitude and azimuth to look at that same top of the tree, you will not be able to use the same coordinates that I provide you if you are standing on the other side of the parking lot. You have to be standing at the same location as I am in order to use the coordinates that I provide you. So altitude and azimuth is often beneficial when you have two observers looking at the same thing from the same location. So if you and I go out, we go out to look at the night sky and I say, oh, check out that constellation over there. Here's the altitude and azimuth. You're located right next to me. You'll be able to use my coordinates to look at the exact same place. So it is more useful when the observers are located in the same location. So in this class, we're going to be focusing on altitude and azimuth. So altitude and azimuth are both values that are reported in degrees. So we use degrees because if we think about it, The Earth is round like a circle, and circles are measured using degrees. And from where we're standing, we look at the sky and it appears to be a dome. So we have all of these circular figures that we're going to be using. So since a circle has 360 degrees, that is the unit that we use when we're reporting our altitude in our azimuth units. Azimuth helps us determine what direction we're looking in. So if we're standing still and we look straight across, we are looking at terms of what direction our body should be positioned to look at that object. So on a horizontal plane, should we be looking straight in front of us? Should we look straight behind us? Should we be looking to the right? Should we be looking to the left? Oftentimes we report azimuth in terms of like north, south, east, west, or in terms of degrees. So 0 degrees is representative of north. East is represented as 90 degrees, south is 180 degrees, west is 270 degrees. Which kind of makes sense here. So if north is here in this direction, east is over here. They create a right angle triangle. We know a right angle triangle to be 90 degrees. So going from 0 to east, that's a 90 degree difference. Same thing as if we go east to south, that's another right angle triangle. There's going to be another 90 degree difference. So from going from 90, an additional 90 degrees is going to give us 180. And we could again continue along the circle doing all of the math. Because first of all, math is the best. But we get another 90 degree right angle triangle here. Or maybe not a triangle, right angle that is there. And 180 plus another 90 degrees gives us 270. And last but not least, we can get another right angle here between west and north. Add another 90. Ooh, that's an ugly degrees. 90 degrees to 270, we get 360. That is why sometimes north is referred to as either 0 degrees or 360 degrees. Because we have done a full, complete circle at that point. So azimuth tells us what direction our body should be pointing. Should it be pointing north, south, east, or west along my horizontal plane? Altitude is referring to the height of the object in relation to the ground. So how high up am I looking? Am I looking straight along the horizon? Am I looking straight up ahead above me? Or am I looking at some sort of angle between the two? Okay. It is thought of as the number of degrees an object is above the horizon. So we say the horizon is at 0 degrees. And straight up above us is going to be 90 degrees. So for altitude, we only have between 0 and 90 degrees because we have a right angle triangle that's, or a right angle that's provided here. So I could be looking in this direction, which I might say is around, 45 degrees. The reason that it doesn't continue here, let me just erase this guy. So if this is 0 degrees from my perspective, I'm going to use a different color. You're right, the pink has already been there, done that. So if I'm looking this way, and this is 0 degrees, and I'm looking straight up, and this is 90 degrees, why can't I continue going around and say, well, this is 180 degrees? Well, the reason being is if I'm facing this way, I'm going to be looking at 0 and 90. I'm not going to tilt my head all the way back to look behind me. Instead, I'm just going to turn to face the other direction. If I turn to face the other direction, my horizon is my 0 degrees, and right above me is 90. So I never need to tilt my head past straight above my head, because if I needed to, I could just turn around and look the other way. So my altitude is always going to be between 0 and 90 degrees. Altitude can never be more than 90. Okay, so altitude refers to, am I looking straight along the horizon? Am I looking straight up or anywhere in between? My azimuth tells me what direction am I facing. Am I facing north, east, south, west, and what direction I should orient my body. All right, so we could try it out. This is an idea of what like a coordinate might look like. So if I'm looking at this here, this particular star, I could picture it as like a right angle triangle here. And I could say, what is the altitude and the azimuth? So looking at my azimuth, I am looking to the right of this diagram here where this arrow is located. That arrow is pointing due east. If I say north is 0, east is 90, south is 180, west is 270, my azimuth would be recorded as 90 degrees because that represents east. Okay. When I'm looking at my altitude here, my altitude is how far am I looking up? Straight above my head is at 90 degrees, straight flat is 0, and that looks pretty smack dab in the middle between 0 and 90. So I might say my altitude is 45 degrees. And that's how I could document my coordinates. So from whatever location I am currently standing in, this is me, hi, I'm standing. My celestial body or the star that I'm looking at is positioned with the azimuth of 90 degrees and the altitude of 45. And someone else who comes along, oh, my friend, who's standing in the same position as I am, I could say, oh, hey, check out that particular star. And they'll say, which one? There's so many in the sky. It's such a beautiful night. Oh. And I'll say, oh, well, the azimuth of 90 degrees and the altitude of 45. And they'll go, oh, yes, such a beautiful star. I'm so glad you pointed it out to me. Then we'll high five in its awesomeness. So altitude and azimuth is actually something we can measure ourselves. Azimuth, you could actually just straight up measure with a compass. So on your device, you should have a compass app that if you point your device in the direction you are facing, it will tell you north, south, east, west, but it will tell you that in degrees. You could also use a real compass, which is something that maybe you've never used in your life. Maybe it's something you have used in your life. But it's something great to bring with you if you ever go hiking or on prolonged backpacking trips or canoe trips because you don't want to get your device wet, or, if your battery dies, it's nice to have a compass. But you could measure an azimuth with a compass. So you could figure out that way. In terms of altitude's a little bit more difficult to measure. It's not something you could use your device for. But you could use a simple device that you could actually make yourself called an astrolabe. So to make one, if you're interested in making one at home, all you do is you take a protractor and you tape a plastic straw to the top. The reason, well, it could be metal straw, reuse, reduce, recycle. But a straw to the top because that provides you a place to look through. So if I was using this device, I would have my eye on one side and I would look through it to look at the particular object. Okay. From there, I would tape on a string right smack dab in the middle of my protractor. And at the bottom of the string, I would place some sort of weight. Because if I just put the string there, the string's not going to fall straight down because it doesn't have the mass to do that. So I could put like a bead. I could tape some sort of washer to it. But something just to weigh it down, and that's cool. So it could be made, just copying the diagram here, using a straw, a thread, a bead, and a protractor. Okay. In order to measure the altitude using this, what you would do is you would look through the straw at some sort of object. So maybe here's a star here that you want to figure out the altitude for. On the one side, you would look through the straw at that object. You would need a person here with you to help you make that recording. But as you are looking through and you're holding that object straight, the astrolabium, the string should fall downwards. And go across a certain reading on the protractor. Your partner, or whoever is there, would then read that reading for you, and that would give you your altitude. So that's kind of cool. Just remember that your altitude can't be greater than 90 degrees. On a protractor, it's the values go up from either end. So you could go from 0 to 180 on one side and then 180 to 0 backwards. So if you are reading a value that is greater than 90, then you are reading the wrong one. So your altitude should only be up to 90 degrees as a maximum. All right, that is it, and that is all for observing celestial bodies. Hope you learned something new, and I can't wait to chat with you soon. Adios, muchachos!